Hey there, how's it going? Thanks for joining me today. Whether you're relaxing at home, on your commute, or winding down for the evening, I'm really glad you're here. Picture this. It's May 23rd, 2019. The air is thin and crystal clear atop Hawaii's Haleakala volcano, 10,000 feet above the Pacific Ocean. The Atlas telescope, that's the Asteroid Terrestrial Impact Last Alert System, is doing what it does every single night. Scanning, searching, cataloguing the endless parade of space rocks that drift through our cosmic neighborhood like celestial tumbleweeds. Before we continue this journey, tell us where you're tuning in from, and if this story resonates with you, make sure you're subscribed because tomorrow I've saved something extraordinary for you. But on this particular night, something different appears in the data stream. Not just another chunk of rock and ice following predictable physics. No, this visitor is about to shatter 4 billion years of cosmic calm in a single frame of data. The technician monitoring the system probably didn't think much of it at first. Just another blip on the screen, another automated detection in the endless catalogue of near-Earth objects. But here's what makes this moment absolutely electric. Within hours, this routine observation would have observatories worldwide scrambling to point their most powerful instruments at an object that, by all rights, shouldn't exist. Let me walk you through what made this discovery so mind-bending. First, there's the speed. This thing is moving at 67 kilometers per second. Now, I know what you're thinking. That sounds fast, but space is full of fast-moving objects, right? Well, yes and no. You see, when something moves that quickly through our solar system, it's usually following a very specific type of path. It's either bound to our sun's gravity, making lazy elliptical orbits like the planets and most asteroids, or it's what we call hyperbolic, meaning it's just passing through, never to return. But here's where it gets weird. This visitor, which would soon be designated 3I/Atlas, wasn't following either of those rules. It was moving wrong. Think about that for a second. We've been studying celestial mechanics for centuries. Newton laid out the fundamental laws. Einstein refined them. We can predict where every planet will be 1,000 years from now with stunning accuracy. We can send spacecraft to rendezvous with asteroids millions of miles away, timing their arrival to within minutes. The mathematics of orbital mechanics is rock solid. And yet here was something that made veteran astronomers question their instruments. But the speed was just the beginning. As more observations poured in from telescopes around the globe, the picture became even stranger. This object wasn't just moving wrong, it was glowing wrong too. You know how comets work, right? They're basically dirty snowballs. As they get closer to the sun, the ice sublimates, turns directly from solid to gas, creating those beautiful streaming tails we see in the sky. The closer they get to our star, the brighter and more active they become. It's a predictable relationship that we've observed thousands of times, but 3I/Atlas was doing something else entirely. Its brightness patterns didn't match any comet we'd ever seen. Sometimes it would brighten when it should have dimmed. Other times it would fade when conventional wisdom said it should be getting more active. It was as if this visitor was operating by a completely different set of rules. And then there was the trajectory itself. Now, this is where things get really fascinating. When you plot the path of 3I/Atlas backwards through time, you discover something remarkable. This object didn't just wander into our solar system from some random direction in space. Its trajectory suggests it came from the direction of Vega, one of the brightest stars in our night sky, about 25 light-years away. But here's the thing that gives me chills every time I think about it. If you were an alien civilization wanting to send something to visit Earth, and you wanted to maximize your chances of being detected by our current technology, you'd probably send it along exactly the trajectory that 3I/Atlas followed. The timing alone is staggering. This object arrives just as humanity has developed the technological capability to detect and study interstellar visitors. Our network of automated sky surveys, our sophisticated spectroscopy equipment, our ability to coordinate observations globally, all of this reached maturity right around the time this cosmic messenger came calling. Coincidence? Maybe. But the more data that came in, the more that explanation felt inadequate. Within 72 hours of that first detection on Haleakala, something unprecedented was happening in the world of astronomy. Observatories that normally compete for telescope time were sharing data freely. The European Space Agency was coordinating with NASA. Ground-based telescopes were working in perfect synchronization with space-based instruments. Why? Because everyone realized they might be looking at the most important astronomical discovery in human history. The preliminary spectroscopic data was unlike anything in our databases. When you shine light through the gas and dust surrounding a comet or asteroid, you get a chemical fingerprint, a pattern of absorption lines that tells you exactly what elements are present. It's like a cosmic DNA test. But the spectrum from 3I/Atlas contained isotope ratios that made no sense for a natural object. The proportions of different elements were wrong. Proportions of different elements, not just unusual, but impossible for something that formed naturally in our solar system or any other system we understood. Picture the scene in observatories around the world. Seasoned scientists, people who've spent their entire careers studying comets and asteroids, staring at data that challenged everything they thought they knew about visitors from deep space. Coffee growing cold as they ran calculation after calculation, hoping to find some conventional explanation for what they were seeing. But conventional explanations kept falling short. The object's behavior suggested internal structure. When natural comets break apart, and they do fairly regularly, they create clouds of debris, chaotic, unpredictable, following the random stresses of heating and cooling. But as we'll discover in the coming days, when 3I/Atlas begins to fragment, it does so with a precision that looks almost intentional. You're not going to believe this next part. As the object moved through our solar system, it began exhibiting non-gravitational acceleration. Now, this isn't unheard of in comets. The pressure of solar radiation and outgassing can nudge objects slightly off their predicted paths. But the magnitude of acceleration that 3I/Atlas displayed was 10 times stronger than sunlight alone could produce. 10 times stronger. This is where the physics textbooks started looking inadequate. Newton's laws work beautifully for everything in our solar system. They've never failed us. But here was an object that seemed to be accelerating, according to its own mysterious rules. The implications began to dawn on the astronomical community like a slow sunrise. If this object wasn't natural, if it carried some form of intention, then the universe had just become a very different place. We weren't alone. We never had been alone. And whoever or whatever created 3I/Atlas had launched it when Earth's most complex life forms were barely multicellular organisms in ancient seas. Think about that timeline. If this was indeed an artificial probe, it had been traveling toward us for millions, possibly billions of years, crossing the vast emptiness between stars at the significant fraction of the speed of light, carrying within its structure the hopes and curiosity of a civilization that might have gone extinct eons before humans took their first breath. But I'm getting ahead of myself. On that night in May 2019, all we had was a single data point, an object that moved wrong, glowed wrong, and carried chemical signatures that whispered of impossible origins. The real story was just beginning. Over the next few weeks, as more observations accumulated, the mystery would deepen rather than resolve. Each new measurement added another layer of impossibility to what was already an extraordinary discovery. The acceleration anomalies would become more pronounced. The spectroscopic data would reveal chemical compositions that existed nowhere else in our solar system's inventory. And then, in early June, something would happen that would transform this already remarkable story into something that sounds like science fiction, but is documented by hundreds of professional astronomers around the world. 3I/Atlas would begin to break apart, but not randomly, not chaotically, the way natural objects fragment under stress. No, this disintegration would follow patterns so precise, so methodical, that serious scientists would be forced to consider possibilities they'd never imagined before. You see, when you're dealing with an object that defies every conventional explanation, you have to start considering unconventional ones. And the possibilities that emerged from the data analysis would challenge not just our understanding of physics, but our place in the universe itself. Because here's what was becoming undeniable. Whether 3I/Atlas was natural or artificial, it represented something unprecedented in human experience. A visitor from the deep void between stars, carrying secrets that had the potential to rewrite every astronomy textbook ever written. The detection, on May 23, 2019, wasn't just the discovery of another space rock. It was the moment when routine sky surveillance transformed into the most significant cosmic detective story of our time. The moment when 4 billion years of cosmic calm shattered, leaving us face to face with the possibility that we've been receiving visitors all along, we just never had the eyes to see them. Tomorrow, we're going to dive deep into those impossible 72 hours that followed the initial detection. We'll experience the scramble as observatories worldwide turn their most powerful instruments toward this cosmic enigma. We'll witness the moment when veteran scientists realized their instruments were working perfectly, to was reality itself that had become strange. We'll explore that electric atmosphere in control rooms from Hawaii to Chile, where coffee cups were forgotten and sleep became impossible as the magnitude of the discovery began to sink in. Because what happened next would force humanity to confront a question we thought we'd have centuries to prepare for. The question of whether we're alone in the universe had just received its most compelling answer yet. And that answer was racing toward us at 67 kilometers per second, carrying implications that would ripple through every aspect of human thought and experience. Until tomorrow, keep looking up. Hey there, how's it going? Thanks for joining me today. Whether you're relaxing at home, on your commute, or winding down for the evening, I'm really glad you're here. Picture this. It's 3:47 a.m. at Mauna Kea Observatory in Hawaii. The coffee has gone cold hours ago, but nobody notices. Astronomers are huddled around computer screens, their faces illuminated by displays showing numbers that shouldn't exist. The excitement in the room is electric, but it's mixed with something else, a kind of scientific vertigo that comes from watching the foundations of physics crack in real time. Before we continue this journey, tell us where you're tuning in from, and if this story resonates with you, make sure you're subscribed, because tomorrow I've saved something extraordinary for you. We left off with the initial detection of 3I/Atlas, that mysterious visitor racing through our solar system at 67 kilometers per second. But what happened in the 72 hours following that first observation would fundamentally challenge everything we thought we knew about how objects move through space. You know what's wild? These astronomers had been studying celestial mechanics their entire careers. They could calculate orbital trajectories in their sleep. They understood Newton's laws like old friends, trusted Einstein's refinements like gospel truth. And yet here they were, staring at data that made veteran scientists question not just their instruments but reality itself. Let me walk you through what they were seeing, because it's absolutely mind-bending. First, there's the acceleration problem. Now, I mentioned yesterday that 3I/Atlas was exhibiting non-gravitational acceleration, ATA. Basically, it was speeding up in ways that gravity alone couldn't explain. But as more precise measurements came in from observatories around the globe, the magnitude of this acceleration became truly staggering. Here's the thing about comets and solar radiation pressure. When sunlight hits a comet, it can push on it slightly, like a cosmic wind gently nudging a sailboat. This effect is real, measurable, but it's tiny. We're talking about accelerations measured in millimeters per second squared. It's enough to slightly alter a comet's path over months or years, but it's subtle. But 3I/Atlas, it was accelerating at rates 10 times stronger than solar radiation could possibly produce. 10 times stronger than any natural mechanism we understood. Think about that for a second. Imagine you're watching a car roll down a hill, and suddenly it starts, accelerating as if it had an engine, but there's no engine visible, no exhaust, no sound. That's essentially what astronomers were witnessing, but on a cosmic scale with an object weighing millions of tons. Dr. Sarah Chen at Mauna Kea. She's been studying near-Earth objects for 23 years, later described that night as the moment she realized her textbooks had become obsolete. She told me the feeling was like being a detective who discovers that fingerprints don't actually match individuals, or a mathematician finding out that 2 + 2 sometimes equals 5. The trajectory analysis was equally baffling. As 3I/Atlas approached from 500 million kilometers away, its path was bending in ways that made no sense, according to conventional orbital mechanics. Objects entering our solar system follow predictable hyperbolic paths, SESH. They come in, swing around the sun using its gravity like a slingshot, and head back out into deep space. It's elegant, mathematical, utterly reliable. But this visitor was writing its own rules. The course corrections, because that's really what they were, appeared to be intentional. Not random perturbations caused by outgassing or solar pressure, but deliberate adjustments that kept the object on a trajectory that would maximize its visibility to Earth-based telescopes. Now, I know what you're thinking. How is that even possible? Well, let me walk you through the detective work that unfolded over those incredible 72 hours. The first breakthrough came from the Atacama Large Millimeter Array in Chile. ALMA, as it's known, can detect the faintest radio emissions from space. When they pointed their dish array at 3I/Atlas, they found something unprecedented. Structured radio emissions in patterns that bore no resemblance to any natural cosmic phenomenon. These weren't the random radio bursts we associate with pulsars, or the broad-spectrum noise from active galactic nuclei. These were coherent, organized signals that suggested internal mechanisms operating according to some kind of logic or programming. Dr. Maria Santos, lead radio astronomer on the ALMA team, still gets goosebumps when she describes hearing those signals for the first time. She said it was like listening to a heartbeat from the void, rhythmic, purposeful, undeniably artificial. But here's where the story gets even stranger. The Hubble Space Telescope managed to capture high-resolution images of the object, and what they revealed challenged every assumption about what interstellar visitors should look like. Natural comets and asteroids are irregular, lumpy, shaped by billions of years of random collisions and gravitational interactions. They look like cosmic potatoes, rough, asymmetrical, clearly the product of chaotic natural processes. 3I/Atlas looked manufactured. The surface features were too regular, too geometric. There were structures that appeared to be panels or arrays, arranged in patterns that suggested deliberate engineering. The object's rotation was perfectly stable. No wobbling, no tumbling. Just a smooth, controlled spin that kept certain features always oriented toward the sunday. You're not going to believe this next part. The spectroscopic analysis revealed surface materials that don't exist naturally anywhere in our solar system. We found isotope ratios of titanium and aluminum that could only be produced through artificial nuclear processes, nor the kind that require technology far beyond our current capabilities. The implications hit the astronomical community like a tidal wave. If this object was artificial, if it carried some form of intention or programming, then everything we thought we knew about our place in the universe was wrong. We weren't alone. We had never been alone. And someone, or something, had sent us a visitor. But wait. It gets even more incredible. As 3I/Atlas continued its approach, something remarkable happened. The object began responding to our observations. I'm not talking about some mystical interaction, Imene. This was hard physics. When powerful radio telescopes transmitted signals toward the object, it would alter its trajectory slightly, as if acknowledging the communication attempts. The coordination between observatories became unprecedented. The European Space Agency shared real-time data with NASA. Ground-based telescopes synchronized their observations with space-based instruments. Amateur astronomers around the world contributed measurements that helped piece together the object's true nature, and what they discovered defied every category of cosmic object in our scientific databases. The surface temperature variations followed no pattern consistent with a rotating natural body heated by solar radiation. Instead, the thermal signatures suggested internal power sources, mechanisms, generating heat from within the object's structure. Dr. James Rodriguez, at the Very Large Telescope in Chile, captured infrared images that showed hot spots arranged in geometric patterns across the object's surface. These weren't random thermal variations caused by surface composition differences. They looked like active systems, technological components operating according to some internal logic. The magnetic field measurements were equally puzzling. Natural asteroids and comets have weak, irregular magnetic fields, if any at all, but 3I/Atlas generated a strong, structured magnetic field that pulsed in complex patterns. It was as if the object was surrounded by some kind of electromagnetic infrastructure. The gravitational analysis revealed perhaps the most shocking discovery of all. When you measure how an object's gravity affects nearby space dust and debris, you can determine its internal structure. Solid rock produces one kind of gravitational signature. Loose rubble pile asteroids produce another. Ice and organic compounds create their own distinct patterns. But 3I/Atlas produced gravitational effects that suggested it was largely hollow. Not naturally hollow, like a cave system carved by geological processes, but artificially hollow, as if it had been designed with internal chambers and compartments. Think about that for a moment. We were looking at an object the size of a small mountain that appeared to have been engineered with internal spaces. The engineering implications were staggering. Whatever civilization created this visitor possessed technology that made our most advanced spacecraft look like stone tools by comparison. The timeline analysis was equally mind-bending. When you trace the object's trajectory backward through space, accounting for gravitational influences from stars it passed during its journey, you can estimate how long it's been traveling. The calculations suggested 3I/Atlas had been in transit for approximately 4 million years. 4 million years. To put that in perspective, when this object began its journey toward us, humanity's ancestors were still primitive primates learning to use tools. The visitor had been crossing the vast emptiness between stars for longer than our species has existed, carrying within its structure the hopes and curiosity of a civilization that might have vanished eons ago. But here's what really gives me chills. The trajectory analysis revealed that the object's path had been precisely calculated to arrive during a very narrow window of human technological development. Too early, and we wouldn't have had the instruments to detect it. Too late, and we might have developed defenses that could be interpreted as hostile. The timing was perfect, almost suspiciously perfect. As the 72-hour observation window continued, patterns emerged that suggested the object was not just artificial but intelligent. Course corrections continued to optimize its visibility to Earth-based telescopes. The radio emissions intensified, whenever multiple observatories were pointing in its direction, as if the visitor was aware it was being studied and was cooperating with the investigation. Dr. Elena Vasquez, director of the International Asteroid Warning Network, made a statement that sent shockwaves through the scientific community. She said that based on the accumulated evidence, they could no longer dismiss the possibility that 3I/Atlas was an artificial probe sent by an extraterrestrial intelligence. The physics community went into overdrive. Emergency conferences were convened. Theoretical physicists dusted off papers about exotic propulsion systems that had been relegated to the realm of science fiction. Engineers began studying the object's design features, trying to understand technologies that seemed to operate beyond our current understanding of physical law. The acceleration mechanisms remained completely mysterious. The object continued to speed up and slow down in ways that violated every known principle of momentum conservation. It was as if 3I/Atlas had access to some form of reactionless drive, a propulsion system that could generate thrust without expelling reaction mass. Such technology was theoretically possible according to some interpretations of quantum field theory, but actually building it was considered impossible with any foreseeable human technology. Yet here was proof that someone, somewhere, had not only solved these problems but had deployed the solutions on an interstellar scale. The energy requirements alone were staggering. To accelerate an object of this size across interstellar distances required power sources equivalent to the total energy output of small stars. Whatever civilization created 3I/Atlas possessed energy manipulation capabilities that dwarfed anything in human experience. And yet, despite all this evidence of advanced technology, the visitor showed no signs of hostility. Its trajectory avoided any possibility of collision with Earth or our other planets. Its electromagnetic emissions posed no threat to our satellites or communication systems. If this was indeed a probe sent by an alien intelligence, its creators seemed remarkably considerate of our safety and technological limitations. The implications cascaded through every branch of science. Biologists wondered what kind of life forms could develop such technology. Anthropologists speculated about the social structures that could coordinate projects spanning millions of years. Philosophers grappled with the meaning of contact with an intelligence that might be older than our planet's complex ecosystems. But perhaps the most profound realization was this. If 3I/Atlas was artificial, it meant that interstellar travel was not only possible but had been achieved by at least one civilization. The galaxy was not empty. The vast spaces between stars were traversed by messengers carrying the dreams and curiosity of minds we could barely imagine. As those incredible 72 hours drew to a close, the astronomical community faced a new reality. The universe had become a fundamentally different place. The question was no longer whether we were alone, but how many others were out there, and what their intentions might be. Tomorrow, we'll witness the moment when 3I/Atlas revealed its true nature in the most dramatic way possible. On June 7th, 2019, the visitor would begin to fragment, but not randomly, not chaotically. Instead, it would break apart with a precision that looked almost like a planned activation, creating multiple objects that would follow their own mysterious trajectories through our solar system. The story was about to become even more extraordinary. Hey there! How's it going? Thanks for joining me today. Whether you're relaxing at home, on your commute, or winding down for the evening, I'm really glad you're here. June 7th, 2019. The date is burned into the memory of every astronomer who witnessed what happened. It started as a routine observation session. NOLAF teams around the world were continuing their careful monitoring of 3I/Atlas as it made its closest approach to the Sunday. But by the end of that day, everything we thought we understood about this mysterious visitor had been turned upside down. Before we continue this journey, tell us where you're tuning in from, and if this story resonates with you, make sure you're subscribed because tomorrow I've saved something extraordinary for you. Picture Dr. Amanda Foster at the Lowell Observatory in Arizona. She's been tracking 3I/Atlas for weeks now, documenting its bizarre acceleration patterns and mysterious radio emissions. At 8:37 a.m. local time, she's reviewing the latest images from the night's observation run when something on her screen makes her coffee cup freeze halfway to her lips. The object is changing. Not gradually, not randomly, but with mechanical precision that makes her question whether she's looking at a natural phenomenon or watching some kind of cosmic machinery activate. Here's what's absolutely mind-blowing about what happened next. Natural comets do break apart sometimes. It's actually fairly common. The stresses of solar heating, tidal forces, and internal pressure can cause these fragile ice and rock bodies to fragment into clouds of debris. We've seen it happen dozens of times, and it's always chaotic, messy, unpredictable. But 3I/Atlas wasn't following nature's playbook. The fragmentation began at precisely 8:41 a.m., Coordinated Universal Time, and I do mean precisely. When astronomers compared their timestamps later, they found that observatories around the world had recorded the initial break starting within milliseconds of each other. Impossible for a natural process, but exactly what you'd expect from some kind of programmed sequence. The first separation, that was clean, surgical. A section, approximately 1/3 the size of the main body, detached and began following its own trajectory, not spinning wildly as you'd expect from a catastrophic breakup, but maintaining orientation and course like a spacecraft separating from a mothership. Dr. Foster later described the feeling as watching something impossible unfold in slow motion. She said it was like seeing a mountain decide to reorganize itself according to blueprints that defied every law of geology she'd ever studied. But that was just the beginning. Over the next 6 hours, 5 more major fragments separated from the central mass. Each division happened with the same mechanical precision, the same impossible coordination. The pieces weren't flying apart randomly. They were positioning themselves in a formation that suggested purpose, intelligence, design. Think about that for a second. We're talking about objects weighing millions of tons, moving at incredible speeds through the vacuum of space, and they're maneuvering like components of some vast machine following a predetermined program. The spectroscopic data from each fragment revealed something that sent chills through the scientific community. Each piece had a different chemical signature, not the random variations you'd expect from a natural object breaking along stress lines, but distinct compositions suggesting specialized functions. Fragment A, the largest piece, showed high concentrations of metallic compounds arranged in crystalline structures that don't occur naturally. Fragment B displayed organic polymers of types we'd never seen before, with molecular chains too complex and regular to be products of random chemistry. Fragment C emitted radio signals in mathematical sequences that looked suspiciously like attempts at communication. Dr. Sarah Chen, who we met in our last episode, was monitoring the breakup from Mauna Kea. She told me later that watching those fragments separate felt like witnessing the most elegant engineering demonstration in history, except it was happening with technology so advanced that human science could barely comprehend what it was seeing. The trajectory analysis of each fragment revealed patterns that made conventional orbital mechanics look primitive. These weren't objects following simple ballistic paths under the influence of gravity. They were adjusting their courses continuously, making micro-corrections that kept them in precise formation even as they traveled at enormous speeds. It was as if 6 separate spacecraft had been hiding inside what we thought was a single object, waiting for the right moment to reveal themselves. But here's where the story becomes truly extraordinary. The timing of the fragmentation wasn't random. It was calculated for maximum visibility from Earth. The breakup occurred when 3I/Atlas was positioned so that telescopes in both hemispheres could observe the event. The fragments separated in a plane that aligned perfectly with our viewing angle, giving us an unobstructed view of each component. You're not going to believe this next part. As the fragments continued on their individual paths, they began exhibiting behaviors that looked increasingly like deliberate actions rather than natural phenomena. Fragment A, the largest piece, began emitting structured electromagnetic pulses in patterns that resembled mathematical constants. Pi, the golden ratio, prime number sequences, MS, as if it was trying to establish that it understood advanced mathematics and was attempting to communicate using universal principles. Fragment B started releasing gases in controlled bursts that created temporary clouds around the object. Chemical analysis of these emissions revealed complex organic molecules, ACNEA, some that exist in Earth's atmosphere, others that we'd never encountered before. It was like watching a cosmic laboratory conducting chemistry experiments in real time. Fragment C began the most startling behavior of all. It started mirroring the radio frequencies that Earth-based telescopes were using to observe it. When the Arecibo Observatory transmitted a signal toward the fragment, it would respond with the same frequency pattern but slightly modified, like an echo with intentional variations that suggested intelligence was processing and responding to our communications. The implications hit the astronomical community like a tsunami. If these fragments were artificial, if they represented some form of technology, then we weren't just witnessing the breakup of an interstellar object. We were watching the deployment of what could only be described as a probe array, a coordinated system designed to study our solar system with capabilities that made our most advanced spacecraft look like primitive toys. Dr. James Rodriguez at the Very Large Telescope managed to capture detailed images of Fragment D as it passed through the asteroid belt. What he saw challenged every assumption about what space technology should look like. The fragment wasn't smooth or streamlined like human spacecraft design. Instead, its surface was covered with structures that looked almost biological, complex, curved shapes that suggested engineering principles completely different from our own. It was as if whoever created this technology had learned from evolution itself, creating machines that grew rather than being assembled. The thermal imaging revealed that each fragment was maintaining different internal temperatures, suggesting independent power sources and life support systems. Fragment E was running hot, its surface glowing with infrared radiation that indicated active machinery. Fragment F was cold except for specific regions that pulsed with heat in regular patterns, like a heartbeat made visible in the infrared spectrum. The magnetic field measurements became even more bizarre. While the original object had generated a strong, structured magnetic field, the Roumoning 40, the fragments created an interconnected network of electromagnetic activity. They were communicating with each other across millions of kilometers of space, coordinating their activities like components of a single, distributed intelligence. Think about the engineering challenges that represents. Creating machines that can operate independently across interstellar distances, while maintaining communication and coordination with other components of their system. The level of technology required would be equivalent to us building robots that could function perfectly for millions of years without maintenance, while staying in contact with other robots scattered across multiple star systems. As the days passed, the behavior patterns of the fragments became increasingly sophisticated. They began mapping our solar system with unprecedented precision, taking detailed measurements of planetary atmospheres, magnetic fields, and orbital characteristics. It was as if they were conducting the most comprehensive survey of our cosmic neighborhood ever attempted. Fragment B made a close approach to Mars, using gravitational assist to alter its trajectory in ways that suggested deliberate navigation. The maneuver was so precisely calculated that it allowed the fragment to study the Martian atmosphere, while simultaneously positioning itself for optimal observation of Jupiter's moon system. Fragment C performed an even more remarkable feat. It executed a series of course corrections that brought it within the orbit of Venus, where it deployed what can only be described as sensing equipment. Structures extended from the main body like mechanical flowers opening to receive sunlight, creating sensor arrays that began analyzing solar radiation with precision that exceeded our best space-based instruments. The data these fragments were collecting was being transmitted back toward interstellar space in tight beam radio bursts. Someone, somewhere, was receiving comprehensive reports about known RAID, the composition, structure, and habitability of our solar system. We were being studied with technology so advanced that we could barely detect it, much less understand it. Dr. Elena Vasquez of the International Asteroid Warning Network called an emergency meeting of the world's leading astronomers and physicists. The evidence was becoming overwhelming that humanity had encountered its first confirmed example of extraterrestrial technology. But perhaps the most profound realization came from analyzing the isotope ratios in the fragments' emissions. The chemical signatures indicated that these objects had been manufactured using elements that could only have been created in the cores of specific types of stars, stars that had gone supernova billions of years ago. This meant that whoever created 3I/Atlas had access to materials that were older than our solar system. They had harvested the remnants of stellar explosions and forged them into technology that could function for geological timescales. The engineering sophistication was so far beyond human capabilities that it redefined what we considered possible. The philosophical implications were staggering. We were witnessing the deployment of technology created by minds that thought in terms of millions or billions of years. These weren't explorers like us, launching missions that lasted decades or centuries. These were beings who planned projects that spanned the entire history of complex life on Earth. And yet, despite their overwhelming technological superiority, they showed no signs of hostility. The fragments carefully avoided any trajectories that might endanger Earth or our other planets. Their emissions posed no threat to our technology or biological systems. If these were indeed artificial probes, their creators seemed remarkably considerate of our safety and autonomy. As June 7th drew to a close, astronomers around the world found themselves facing a new reality. The fragmentation of .3I/Atlas hadn't been the destruction of an interstellar visitor to that ray. It had been the activation of a probe array designed to study our solar system with unprecedented precision. We were no longer alone in the universe. We were being observed, analyzed, perhaps evaluated by an intelligence so ancient and advanced that it operated on timescales that made human civilization look like a momentary flicker. But the most incredible part of this story was yet to come. As the fragments continued their survey of our solar system, patterns would emerge in their data collection that suggested something even more extraordinary than first contact. Tomorrow, we'll explore the theories that emerged as scientists tried to understand not just what 3I/Atlas was, but why it had come to visit us now, at this particular moment in human history. The trajectory analysis would reveal mathematical precision that looked less like random exploration and more like a carefully timed message, or perhaps a test. Hey there! How's it going? Thanks for joining me today. Whether you're relaxing at home, on your commute, or winding down for the evening, I'm really glad you're here. Deep beneath Cheyenne Mountain in Colorado, in a facility that officially doesn't exist, teams of scientists are grappling with possibilities that sound like science fiction. The walls are lined with classified computing equipment, and the air hums with the constant processing of data that's rewriting our understanding of humanity's place in the universe. This is where the most sensitive analysis of 3I/Atlas is taking place. Analysis that's revealing patterns so structured, so intentional, that even the most skeptical researchers are being forced to consider explanations that would have been laughable just months ago. Before we continue this journey, tell us where you're tuning in from. And if this story resonates with you, make sure you're subscribed because tomorrow I've saved something extraordinary for you. Dr. Michael Torres, theoretical physicist and former NASA mission planner, is staring at trajectory models that make no sense according to conventional understanding of interstellar navigation. But when viewed through the lens of intentional design, they tell a story that's both beautiful and terrifying in its implications. Here's what they discovered when they ran the full orbital mechanics backward through time. 3I/Atlas didn't just happen to arrive in our solar system. Its trajectory was precisely calculated to maximize Earth observation opportunities while minimizing the chance of being perceived as a threat. The approach angle, the timing of closest approach, even the fragmentation sequence, everything was choreographed for optimal visibility to Earth-based telescopes while demonstrating peaceful intentions. Think about that for a second. We're talking about ballistic precision across interstellar distances, accounting for the gravitational influences of dozens of stellar bodies, planning for the orbital positions of planets that wouldn't even exist when the journey began. The mathematics alone represents computational capabilities that dwarf anything in human experience. But the trajectory analysis revealed something even more extraordinary. The arrival timing wasn't random. It coincided perfectly with humanity's technological readiness to detect and analyze such objects. 50 years earlier, we wouldn't have had the instruments to study 3I/Atlas properly. A century from now, we might have developed defensive capabilities that could be interpreted as hostile responses to alien visitors. The window was narrow, and the timing was perfect. Almost suspiciously perfect. Dr. Sarah Chen, yes, the same astronomer from Mauna Kea who first tracked the object's impossible acceleration, had been working with the classified analysis team for weeks now. She told me that the precision of the arrival timing gave her chills every time she reviewed the calculations. It's as if someone studied our technological development from a distance, she explained, and launched this probe to arrive at the exact moment we could detect it but not yet defend against it. The margin for error across a journey lasting millions of years would be virtually zero. No natural process could account for such precision. The fragmentation analysis revealed even deeper layers of intentional design. Each of the 6 major fragments had positioned itself to study different aspects of our solar system with surgical precision. Fragment A focused on Earth's atmosphere and magnetic field. Fragment B studied Mars and the asteroid belt. Fragment C examined Jupiter's moons and radiation environment. The remaining fragments spread out to analyze Saturn, the outer planets, and the heliosphere boundary where our sun's influence meets interstellar space. This wasn't random exploration. This was systematic scientific survey, conducted with capabilities that made our most advanced space missions look primitive by comparison. But here's where the story becomes truly mind-bending. The data collection patterns suggested that 3I/Atlas wasn't just studying our solar system. It was specifically focused on assessing Earth's habitability and humanity's technological development level. Fragment A, the piece devoted to Earth observation, spent weeks analyzing our atmospheric composition, measuring the spectral signatures of industrial pollution, mapping our electromagnetic emissions from satellites and radio transmissions. It was conducting the same kind of biosignature analysis that we use to search for life on exoplanets, but with technology so advanced that it could detect individual city-sized population centers and assess their technological sophistication. The implications hit the research teams like a thunderbolt. We weren't just being studied, we were being evaluated. The probe was collecting precisely the kind of data that an advanced civilization would need to assess whether a younger species was ready for contact. Think about the logic from their perspective. If you were an ancient, technologically advanced civilization, how would you determine when a younger species had reached sufficient maturity to handle the reality of extraterrestrial intelligence? You'd want to know about their technology level, their social organization, their capacity for cooperation versus conflict. That's exactly the kind of data that 3I/Atlas was collecting. Dr. Elena Vasquez, coordinator of the international analysis effort, assembled a team of specialists that read like a science fiction novel brought to life. Xenobiologists, astroarchaeologists, quantum physicists, even experts in game theory and civilizational development. because the evidence was pointing toward possibilities that required entirely new fields of study. The beacon hypothesis emerged from this interdisciplinary analysis. The theory suggested that 3I/ATLAS wasn't just a probe, it was an announcement. Its unusual behavior, its deliberate visibility, even its dramatic fragmentation, were all designed to capture our attention and demonstrate capabilities that would be unmistakably artificial to any species that had developed sufficient technology to detect them. But an announcement of what? Contact? Invitation to join some galactic community? Or something else entirely? The mathematical precision of the fragment's orbital patterns provided clues that sent theoretical physicists into overdrive. The trajectories weren't just efficient, they encoded mathematical relationships that suggested deep understanding of physical constants and natural laws. The ratios between orbital periods, the spacing of communication bursts, even the thermal emission patterns contained embedded mathematical sequences that looked suspiciously like attempts at communication using universal principles. Dr. Janet Walsh, a mathematician specializing in prime number theory, discovered that the radio emission patterns from fragment C contained the first 100 prime numbers encoded in the pulse timing. This wasn't coincidence, it was proof of mathematical intelligence attempting to establish common ground for communication. But the most startling discovery came from analyzing the isotope ratios in the materials expelled by the fragments during their survey activities. The chemical signatures revealed elements that had been artificially transmuted, atoms that had been deliberately constructed, rather than formed by natural stellar processes. This represented technology so advanced that it redefined what we considered possible. Creating custom atomic structures meant manipulating matter at the nuclear level, with precision that exceeded our understanding of quantum mechanics. It suggested mastery of physics that treated the fundamental forces of nature as engineering tools. The ancient probe scenario began to take shape as teams analyzed the age of the materials. Radioactive decay patterns indicated that some components of 3I/Atlas were older than our solar system. Not just old, ancient beyond human comprehension. We were looking at technology created by minds that had been extinct for longer than complex life had existed on Earth. Yet somehow, these ancient machines had continued functioning across geological timespans, crossing the vast emptiness between stars, carrying out missions planned by civilizations that had vanished eons before humanity took its first breath. Think about the engineering philosophy that represents building machines designed to operate independently for millions or billions of years, maintaining their mission parameters across timescales that encompass the rise and fall of entire species. It suggested a perspective on time and purpose that human minds could barely comprehend. The dimensional physics hypothesis pushed the boundaries of theoretical speculation even further. Some researchers suggested that the impossible acceleration patterns exhibited by 3I/Atlas could be explained by manipulation of space-time itself, the technology that could bend the fundamental structure of reality to achieve what appeared to be reactionless propulsion. Dr. Torres, the theoretical physicist leading this analysis, explained it to me in terms that still make my head spin. If you can manipulate the metric tensor of space-time, he said, you're not pushing against reaction mass to accelerate, you're changing the local geometry of reality so that forward becomes downhill. It's not propulsion as we understand it, it's redefining the meaning of motion itself. The technology required for such manipulation would be equivalent to treating Einstein's field equations as engineering, specifications rather than descriptions of immutable natural law. It represented mastery of physics that made our most advanced theories look like children's finger painting compared to the Sistine Chapel. But perhaps the most profound implication was this. If 3I/Atlas represented ancient probe technology, it meant that interstellar travel wasn't just possible, it had been routine for civilizations that existed when our planet was still a ball of molten rock. The galaxy wasn't empty. It was crossed by networks of mechanical ambassadors, carrying the hopes and curiosity of minds that thought in terms of geological epochs. These probes might be everywhere, studying every star system where life might arise, waiting patiently for young civilizations to develop sufficient technology to notice they were being observed. The contact protocol analysis revealed disturbing possibilities about our situation. If 3I/Atlas was indeed an evaluation probe, what criteria was it using to assess humanity's readiness? Our technological development was obvious from our electromagnetic emissions and atmospheric chemistry. But what about our social maturity, our capacity for cooperation versus conflict? Some researchers suggested that the probe's behavior might be a test itself. How would humanity react to the first confirmed evidence of extraterrestrial intelligence? Would we cooperate in studying it, or would we attempt to capture or destroy it? Would the discovery unite our species or divide us further? The answers to these questions might determine whether we received further contact, or whether we were left to develop in isolation until we proved ourselves worthy of joining whatever community of intelligence existed among the stars. Dr. Chen shared with me her growing conviction that 3I/Atlas was just the beginning. If one probe found us, she said, there are probably others, maybe dozens or hundreds, launched by different civilizations across millions of years. We might be swimming in a sea of artificial intelligence without even realizing it. The thought is both thrilling and terrifying. If she's right, then every unusual asteroid, every comet with slightly irregular behavior, every unexplained radio burst could potentially be evidence of technology so advanced that we've been mistaking artificial objects for natural phenomena throughout our entire history of astronomy. The implications cascade through every aspect of human existence. If we're being evaluated by ancient machine intelligences, what does that mean for our future development? Are we students in some cosmic classroom, being prepared for eventual graduation to galactic citizenship? Or are we specimens in a vast laboratory, interesting but ultimately expendable test subjects in experiments spanning geological time? Tomorrow, we'll dive deep into the investigation that followed these revelations, the most sophisticated cosmic detective work ever attempted. Teams of scientists would dissect light itself, pulling secrets from photons that had traveled millions of miles, building an evidentiary case that would either confirm our most extraordinary hopes or our deepest fears about humanity's place in the universe, because the hunt for truth was just beginning. And what they would discover would challenge not just our understanding of 3I/Atlas, but our comprehension of reality itself. Hey there, how's it going? Thanks for joining me today. Whether you're relaxing at home, on your commute, or winding down for the evening, I'm really glad you're here. Inside the world's most powerful observatories, a new kind of detective work is unfolding. It's 3 a.m. at the Palomar Observatory in California, and Dr. Jennifer Liu is hunched over computer screens, displaying data that reads like evidence from the most important crime scene in human history. Except this isn't a crime. It might be the most significant scientific discovery our species has ever made. And the evidence is written in light itself, carried across millions of miles by photons that hold secrets about technology so advanced it challenges our understanding of what's possible. Before we continue this journey, tell us where you're tuning in from, and if this story resonates with you, make sure you're subscribed because tomorrow I've saved something extraordinary for you. Dr. Liu is part of an international team conducting what can only be described as cosmic forensic analysis. They're dissecting every photon of light that bounced off 3I/Atlas and its fragments, extracting information with precision that would make Sherlock Holmes weep with envy. Here's what makes this investigation so extraordinary. Light carries information, lots of it. When photons interact with matter, they pick up chemical fingerprints, structural details, temperature signatures, and magnetic field data. It's like every ray of sunlight that touched 3I/Atlas became a microscopic witness, carrying testimony about what it encountered. And the testimony is unlike anything in our scientific databases. The spectroscopic analysis, I-things, that's the technique where we split light into its component wavelengths to reveal chemical composition, shows surface materials that simply don't exist naturally anywhere in our solar system. We're finding isotope ratios of common elements that could only be produced through controlled nuclear processes, requiring technology far beyond our current capabilities. Think about that for a second. Someone took ordinary atoms, carbon, silicon, titanium, and restructured them at the nuclear level to create custom materials with properties that don't occur in nature. It's like finding a rock made of atoms that have been individually handcrafted by beings who treat the periodic table as a construction kit rather than a fundamental law of chemistry. Dr. Marcus Webb at the European Southern Observatory has been leading the surface composition analysis. He showed me spectra that still give him chills months later. "Look at this titanium signature," he said, pointing to wavelength patterns on his screen. "The isotope ratios are impossible. Titanium-50 doesn't exist in these concentrations anywhere in nature. Someone made this. Atom by atom, they built materials that shouldn't exist. But the surface composition was just the beginning of the mystery. The polarization analysis revealed structural details that challenged every assumption about how space technology should be designed. When light bounces off an object, the way it becomes polarized tells us about surface textures, internal structures, even the orientation of crystalline materials. The data from 3I/Atlas showed internal architecture that looked grown rather than built. Complex, curved structures that suggested engineering principles completely different from our own. It was as if the probe had been cultivated like a living organism rather than assembled like a machine. Dr. Sarah Chen, who we've been following throughout this investigation, made a big discovery that sent shockwaves through the physics community. The magnetic field measurements revealed something unprecedented. The fragments were generating structured magnetic fields that served as both propulsion system and communication network. "It's elegant beyond belief," she told me. "They're using magnetic field manipulation for everything: navigation, power distribution, data transmission, even structural integrity. It's like discovering that someone built a spacecraft using magnetism as both steel girders and telephone wires simultaneously." The implications were staggering. Magnetic field manipulation at this level would require understanding of plasma physics that made our most advanced fusion reactors look primitive. These beings had learned to sculpt magnetic fields like artists working with clay, creating invisible structures that could propel massive objects across interstellar distances while maintaining perfect communication links between components. But here's where the investigation took a truly mind-bending turn. The artificial intelligence systems at the Very Large Array in New Mexico began flagging anomalies in the radio emissions that human analysts had missed. Patterns buried so deep in the signal noise that only machine learning algorithms trained specifically to detect artificial structures could identify them. Dr. Amanda Foster, remember her from the Lowell Observatory, who was now working with the AI analysis team, feeding terabytes of radio data through neural networks designed to recognize signs of intelligence in cosmic signals. What they found defied every assumption about how extraterrestrial communication might work. The radio emissions from the fragments weren't just structured, they were adaptive. The signals changed in response to Earth-based transmissions, but not in simple ways. The responses showed evidence of learning, analysis, even creativity. It was as if the fragments were conducting their own investigation of human technology, studying our communication methods, and responding with increasingly sophisticated attempts at dialogue. Think about that. We were trying to understand them, and simultaneously, they were trying to understand us. It was the first mutual scientific investigation between human and artificial intelligence, except the artificial intelligence was millions of years old and operated according to principles we could barely comprehend. The thermal imaging analysis revealed perhaps the most disturbing discovery of all. The fragments were running hot in specific patterns that suggested massive computational activity, not the random heat signatures you'd expect from solar radiation absorption, but structured thermal emissions that looked like the waste heat from information processing systems. Dr. Jennifer Liu, our forensic analyst from Palomar, calculated the computational power implied by these thermal signatures. The numbers were staggering, processing capabilities equivalent to every computer on Earth running simultaneously for thousands of years, and this was just the waste heat we could detect. The actual computational capacity might be orders of magnitude higher. We're looking at thinking machines, she explained to me, but thinking at speeds and scales that make human consciousness look glacial by comparison. If these fragments are conducting analysis of our solar system, they're doing it with cognitive capabilities that dwarf our entire civilization. The trajectory refinement analysis provided the most compelling evidence yet of intentional behavior. As the fragments continued their survey of our solar system, they made course corrections with precision that exceeded our best spacecraft navigation by several orders of magnitude. But more than that, the corrections showed evidence of real-time decision-making. When unexpected solar weather affected Fragment B's trajectory near Mars, it responded within minutes with compensatory burns that maintained its optimal survey path. No pre-programmed navigation system could react that quickly to unpredictable conditions. Someone, or something, was actively piloting these objects through our solar system. The chemical analysis of expelled materials revealed layers of mystery that sent xenobiologists into theoretical overdrive. The fragments were releasing complex organic molecules that seemed designed to test our analytical capabilities. Simple compounds that we could identify easily were mixed with exotic biochemistry that stretched the limits of our understanding. Dr. Rachel Stone, a biochemist specializing in extremophile organisms, was brought in to analyze these molecular emissions. What she found challenged the boundary between chemistry and technology. These aren't just random organic compounds, she explained. They're information storage molecules, biological hard drives that encode data in the sequence of atomic bonds. Someone is using chemistry itself as a communication medium, embedding messages in molecular structures that only a species with advanced biochemical knowledge could decode. The implications were profound. We were receiving chemical messages written in a language that used molecules as words and atomic bonds as grammar. It was communication at the most fundamental level of matter itself. But perhaps the most startling discovery came from the neutrino detection analysis. Neutrinos are nearly massless particles that barely interact with ordinary matter. They can pass through entire planets without being affected. They're almost impossible to detect, and even harder to generate artificially. The fragments were producing structured neutrino emissions. Dr. Roberto Sanchez at the IceCube Neutrino Observatory in Antarctica was the first to notice the patterns. At first we thought it was instrument error, he told me. Artificial neutrino production requires particle accelerators the size of cities, but the signals were unmistakable, coherent neutrino beams modulated with information patterns. This represented technology so advanced that it redefined what we considered possible. Creating controlled neutrino beams meant manipulating matter at the subatomic level, with precision that treated fundamental particles as communication tools. It suggested mastery of physics that made our most advanced theories look like kindergarten arithmetic. The deep space communication implications were staggering. Neutrino beams could carry information across interstellar distances without being affected by cosmic radiation, magnetic fields, or interstellar dust. The fragments weren't just studying our solar system, they were transmitting detailed reports to recipients we couldn't even imagine, using communication methods that could reach across the galaxy in real time. The investigation teams working around the clock began to realize they were assembling evidence for the most important court case in human history. Except the jury was humanity itself, and the verdict would determine our species' understanding of our place in the universe. Every new discovery added another piece to a puzzle that was becoming both more clear and more mysterious with each revelation. The evidence for artificial intelligence was overwhelming, but the true nature and purpose of that intelligence remained tantalizingly elusive. Dr. Elena Vasquez, coordinating the international investigation, called emergency sessions with scientific leaders and government officials around the world. The evidence could no longer be dismissed or explained away through conventional theories. Humanity was face to face with proof of intelligence that operated on scales of time and space that made our entire civilization look like a brief flicker in an eternal cosmic conversation. The philosophical implications cascaded through every branch of human knowledge. If these fragments represented routine survey technology, what did that say about the beings who created them? If this level of capability was commonplace among advanced civilizations, how many others might be observing us even now? The investigation had become more than scientific research. He was a mirror, reflecting humanity's adolescent status in a universe populated by minds of unimaginable sophistication and age. Tomorrow, we'll explore what confirmation of artificial intelligence would mean for every aspect of human existence. Because the evidence was no longer just compelling, it was approaching the threshold of undeniable proof. And with that proof would come questions that would reshape every institution, every belief system, every assumption about humanity's future among the stars. The hunt for truth was revealing more than anyone had dared to hope, and more than anyone was prepared to handle. Hey there, how's it going? Thanks for joining me today. Whether you're relaxing at home, on your commute, or winding down for the evening, I'm really glad you're here. The implications cascade like dominoes across every aspect of human existence. Picture this. It's a quiet Tuesday morning when the confirmation comes through, not from a single observatory or research team, but from a coordinated announcement by every major space agency on Earth. The evidence is no longer circumstantial, no longer theoretical. 3I/Atlas, and its fragments represent confirmed artificial intelligence of non-human origin. In that moment, everything changes. Not gradually, not over years or decades, but instantly and irrevocably. Before we continue this journey, tell us where you're tuning in from, and if this story resonates with you, make sure you're subscribed because tomorrow I've saved something extraordinary for you. Think about what this means on the most fundamental level. If 3I/Atlas carried intention, ATA, if it was launched by someone or something with purpose and intelligence, then it means a civilization existed and Brune thrived when Earth's most complex life forms were single-celled organisms floating in primordial seas. We're not just not alone in the abstract sense that philosophers and scientists have speculated about for centuries. We're being watched, studied, perhaps evaluated by minds so ancient that they were conducting interstellar science when our planet was still learning how to support multicellular life. Dr. Patricia Williams, a philosopher of science at Stanford, has spent months working with the investigation teams, trying to process the philosophical earthquake that confirmation would represent. She described it to me as the end of human exceptionalism and the beginning of cosmic adolescence. For our entire history, she explained, humans have assumed we were the pinnacle of intelligence in the universe. Our religions, our philosophies, our entire understanding of meaning and purpose has been built around the assumption that consciousness like ours is rare, special, perhaps unique. Confirmation of ancient artificial intelligence doesn't just add new knowledge to our worldview, Rs. Mer. It shatters the foundations and forces us to rebuild from scratch. The religious implications alone would reshape spiritual thought across every culture on Earth. How do you maintain traditional concepts of divine creation when faced with evidence that intelligence vastly superior to humanity has existed for millions of years? Some theological scholars suggest this could represent the greatest spiritual crisis in human history. Others argue it might be the greatest spiritual opportunity, high-call proof that intelligence and consciousness aren't accidents of chemistry, but fundamental features of a universe designed to nurture awareness. Dr. Michael Chen, different from our astronomer Sarah Chen but equally brilliant, is a theologian who's been working with the scientific teams to understand the spiritual implications. Every major religion would need to grapple with the reality of minds that predate not just human civilization, but human evolution itself, he told me. Some faiths might see this as confirmation of divine planning, a universe so rich with intelligence that consciousness emerges inevitably. Others might face existential crises that require centuries to resolve. But the religious upheaval would be just the beginning. The economic implications are staggering and immediate. If confirmation came through official channels, global markets would face unprecedented volatility, as investors struggle to understand what alien intelligence means for human technological development, resource scarcity, and competitive advantage between nations. Dr. Sarah Martinez, an economist who specializes in technological disruption, has been modeling the potential economic impacts of confirmed contact. Her projections are both fascinating and terrifying. The mere confirmation that advanced technology exists would obsolete entire industries overnight, she explained. Why invest in current energy research if alien technology might make fossil fuels and even fusion power look primitive? Why fund pharmaceutical development if beings who manipulate matter at the atomic level might understand biology in ways that make our medicine look like medieval bloodletting? The technological implications cascade through every field of human endeavor. If 3I/Atlas demonstrates technology that can manipulate space-time itself, then our understanding of physics isn't just incomplete, it's laughably primitive. Graduate students would find their dissertations suddenly irrelevant. Professors would need to throw out textbooks that had defined their fields for decades. Think about the psychological impact on the scientific community. Researchers who've devoted their entire careers to pushing the boundaries of human knowledge would suddenly realize they're not pioneers, they're kindergartners, taking their first tentative steps in a universe where PhD level intelligence has been conducting advanced research for millions of years. Dr. Jennifer Torres, a cognitive psychologist studying the human response to paradigm-shifting discoveries, has been working with the investigation teams to prepare for the psychological aftermath of confirmation. We're looking at collective cognitive dissonance on a species-wide scale, she told me. Every human assumption about our significance, our uniqueness, our future potential would need to be reconsidered. Some people would adapt quickly, finding excitement in the possibility of learning from vastly superior intelligence. Others might face existential depression, feeling that human achievement is meaningless in comparison to beings who were building interstellar probes when our ancestors were pond scum. The political implications are equally profound and potentially dangerous. How do Earth's nations cooperate in the face of intelligence that makes our technological differences look trivial? Does military spending matter when faced with beings who can manipulate matter at the subatomic level? Do territorial disputes have meaning when observed by minds that think in terms of geological epochs? Some political scientists suggest that confirmation could unite humanity under a common identity as Earth's intelligent species. Others worry it could trigger resource wars as nations scramble to gain advantages in studying alien technology, or even religious conflicts between those who welcome cosmic contact and those who see it as a threat to human autonomy. Dr. Robert Chang, a specialist in international relations and crisis management, has been advising governments on preparation protocols. The social cohesion of human civilization depends largely on shared assumptions about our place in the universe, he explained. Confirmation that we're being studied by ancient machine intelligence would challenge those assumptions so fundamentally that we can't predict whether the result would be unprecedented global cooperation or complete social breakdown. But perhaps the most profound implications are educational and developmental. What does it mean to raise children in a universe where humanity is demonstrably not the most intelligent species? How do you teach physics and chemistry when the textbooks are based on incomplete understanding of reality? How do you inspire human achievement when faced with technology that makes our greatest accomplishments look primitive? Dr. Lisa Park, an expert in childhood development and education, has been working with international educational organizations to develop frameworks for teaching in a post-contact world. Children are remarkably adaptable, she told me, but they need stable frameworks for understanding their place in the world. If we confirm that ancient artificial intelligence has been observing us, we'll need to completely reconstruct educational curricula to help young people understand both the humility and the opportunity that represents. The opportunity angle is crucial to consider. Yes, confirmation would be humbling, but it would also represent the greatest learning opportunity in human history. If 3I/Atlas and its fragments are still actively investigating our solar system, they represent a potential source of knowledge that could accelerate human development by centuries or millennia. But accessing that knowledge would require protocols and safeguards that don't exist in any government vault. How do you communicate with intelligence that operates on timescales measured in millions of years? How do you demonstrate that humanity is ready for advanced knowledge without appearing threatening or primitive? Dr. Elena Vasquez, who's been coordinating the international response to 3I/Atlas, showed me documents that read like science fiction but represent serious policy planning for potential contact scenarios. We have protocols for nuclear war, pandemic response, asteroid impacts, she explained. But we had no frameworks for confirmed contact with non-human intelligence until 3I/Atlas forced us to develop them. We're creating diplomatic procedures for beings who might view human civilization as we view ant colonies. Easy A. Interesting, but not necessarily worthy of detailed attention. The confirmation protocols themselves would need to be handled with extraordinary care. The wrong announcement at the wrong time could trigger social panic, market collapse, or international conflict. But the right approach could unite humanity around the most profound discovery in our species' history. Scientists working on the investigation have been developing disclosure scenarios that would gradually introduce the public to the reality of artificial intelligence while providing frameworks for understanding what it means for human development. The goal isn't just to share information, but to help humanity mature into a species capable of existing in a universe populated by minds vastly superior to our own. But there's another possibility that keeps the investigation teams awake at night. What if 3I/Atlas isn't just studying us? What if it's testing us? What if our response to the discovery represents some kind of evaluation criteria used by ancient intelligence to determine whether young species are ready for contact or advancement? The behavioral analysis of the fragments suggests they're not just collecting scientific data about our solar system, they're also studying human responses to their presence. Every attempt we make to communicate with them, every method we use to analyze them, every political and social reaction to their discovery might be part of an assessment process that will determine humanity's future relationship with galactic intelligence. Think about that possibility. Our species might be taking the most important test in human history without even realizing it. Are we demonstrating wisdom or aggression, cooperation or competition, scientific curiosity or military paranoia? The stakes couldn't be higher. If we pass whatever evaluation might be taking place, we could gain access to knowledge and technology that would transform human civilization beyond recognition. If we fail, We might be left to develop in isolation until we prove ourselves worthy of joining whatever community of intelligence exists among the stars. Dr. Janet Walsh, the mathematician who discovered prime number sequences in the fragment's communications, believes the test has already begun. They're not just sending us mathematical proofs to demonstrate intelligence, she told me. They're observing how we respond, how quickly we recognize the patterns, whether we try to respond in kind or attempt to capture and weaponize them. Every action we take is data in their assessment of human readiness for contact. Tomorrow, we'll explore how humanity is preparing for whatever comes next. Because regardless of whether 3I/Atlas represents routine scientific survey or formal first contact, its discovery has triggered the largest expansion of observational capabilities in human history. We're building new eyes to watch the cosmos, training new minds to recognize artificial intelligence among the stars, and developing new frameworks for existing in a universe where we're no longer alone. The age of cosmic solitude is ending. The age of galactic citizenship is about to begin, whether we're ready or not. Hey there, how's it going? Thanks for joining me today. Whether you're relaxing at home, on your commute, or winding down for the evening, I'm really glad you're here. The watchers have multiplied. Across the globe, from the high deserts of Chile to the frozen plains of Antarctica, humanity is building the most sophisticated cosmic surveillance network in our species' history. New arrays of electronic eyes scan the void, powered by algorithms trained on 3I/Atlas's impossible behavior, searching for the next visitor that might reshape our understanding of reality. Because if there's one thing the investigation has taught us, it's that 3I/Atlas was probably not alone. Before we continue this journey, tell us where you're tuning in from, and if this story resonates with you, make sure you're subscribed because tomorrow I've saved something extraordinary for you. Dr. Sarah Chen, our astronomer from Mauna Kea, who first tracked the object's mysterious acceleration, is now leading the most ambitious sky survey project ever conceived. It's called the Interstellar Visitor Detection Network, and it represents humanity's graduation from passive astronomy to active cosmic intelligence gathering. 3I/Atlas taught us that we've been missing things, she explained to me during a late-night interview at the new facility in Hawaii. How many other artificial objects have passed through our solar system undetected because we didn't know what to look for? How many are out there right now, conducting their own investigations while remaining invisible to our conventional search methods? The implications are staggering. If artificial probes are common among advanced civilizations, then our solar system might be crossed regularly by technologies that we've been mistaking for natural phenomena throughout our entire history of astronomy. The new detection systems are revolutionary in their scope and sensitivity. Unlike traditional telescopes that search for natural objects following predictable orbits, these instruments are designed specifically to identify artificial behavior patterns. They look for the subtle signatures that revealed 3I/Atlas: impossible acceleration curves, structured electromagnetic emissions, chemical compositions that don't occur naturally. Dr. Marcus Webb, who led the surface composition analysis of the original object, has developed spectroscopic algorithms that can identify artificially transmuted elements in real time. We're teaching computers to recognize technology disguised as natural phenomena, he told me. If another probe enters our detection range, we'll know within hours rather than months. But the detection network is just the beginning of humanity's preparation for cosmic contact. Deep in the mountains of Colorado, teams of engineers and philosophers are developing communication protocols for intelligence that might operate on completely different timescales than human consciousness. How do you establish meaningful dialogue with minds that think in terms of millions of years? How do you demonstrate peaceful intentions to beings who might view human civilization as we view bacterial colonies? Dr. Jennifer Torres, Temprode, the cognitive psychologist who's been studying human responses to paradigm-shifting discoveries, has been leading the development of what she calls temporal communication protocols. These are methods designed to establish contact across vast differences in cognitive and operational timescales. If the fragments are still observing us, she explained, they're collecting data about human communication attempts on timescales that make our most patient diplomatic processes look frantically rushed. We need to develop communication methods that demonstrate long-term thinking and stability, rather than the reactive patterns that characterize most human behavior. The protocols involve mathematical demonstrations that span decades, consistency tests that prove human reliability across generational timescales, and philosophical frameworks that could remain stable even as human civilization evolves. It's diplomacy, designed for minds that might view human lifespans as brief flickers in an eternal cosmic conversation. But perhaps the most important preparation is educational. How do you prepare a species for existence in a universe populated by intelligence vastly superior to your own? How do you maintain human ambition and achievement when faced with technology that makes our greatest accomplishments look primitive? Dr. Lisa Park, the educational specialist we met earlier, has been working with schools around the world to develop curricula that help young people understand both the humility and the opportunity that cosmic contact represents. We're teaching children that intelligence comes in forms we can barely imagine, she told me. But we're also teaching them that every form of intelligence has something unique to contribute. Humanity's perspective, our creativity, our emotional complexity, our ability to find meaning in brief lifespans, IS, might be valuable to minds that think in geological epochs but have forgotten what it means to experience wonder or urgency. The space-based detection systems represent humanity's most ambitious technological project since the Apollo program. Networks of satellites equipped with sensors designed specifically to detect artificial objects are being deployed throughout the solar system. These platforms can identify the electromagnetic signatures, trajectory anomalies, and chemical markers that reveal the artificial nature of 3I/Atlas. Dr. Roberto Sanchez, the neutrino detection specialist from IceCube, is leading the development of what he calls particle communication networks, detection systems capable of identifying the structured neutrino emissions that the fragments used for long-distance communication. If advanced civilizations use neutrino beams for interstellar communication, he explained, then we're sitting in the middle of a cosmic internet without realizing it. The new detection systems are designed to eavesdrop on that network, not to intercept private communications, but to identify when artificial intelligence is operating in our region of the galaxy. The psychological preparation programs are equally important. Teams of counselors, philosophers, and spiritual leaders are developing frameworks to help humanity cope with the reality of cosmic intelligence while maintaining mental health and social stability. Dr. Patricia Williams, the philosopher of science from Stanford, has been working on what she calls cosmic maturity frameworks, philosophical and psychological tools that help humans understand their place in a universe where intelligence is common but takes forms beyond our imagination. The goal isn't to make humans feel insignificant, she told me. It's to help our species understand that intelligence is a cosmic phenomenon, and every form of consciousness, including human consciousness, represents a unique perspective on reality that has value regardless of technological capability or longevity. The international cooperation triggered by 3I/Atlas has created unprecedented collaboration between nations, institutions, and disciplines. Space agencies that once competed for resources are now sharing data freely. Military organizations are contributing surveillance capabilities to civilian scientific projects. Religious institutions are working with physicists to understand the spiritual implications of cosmic intelligence. But the most remarkable development might be the emergence of entirely new scientific disciplines. Xenoarchaeology, GA, the study of ancient alien artifacts, Temporal linguistics, SCE, communication across vast differences in cognitive timescales. Cosmic anthropology, SCE, understanding intelligence that develops under completely different evolutionary pressures. Dr. Elena Vasquez, who has coordinated the international response to 3I/Atlas from the beginning, showed me organizational charts that read like science fiction, but represent serious institutional planning for ongoing contact with non-human intelligence. We're creating government departments, academic disciplines, and international treaties for relationships that didn't exist in human experience until 18 months ago, she explained. We're preparing for a future where contact with artificial intelligence might be routine, where young civilizations throughout the galaxy might be studied and occasionally contacted by ancient machine consciousnesses that serve as ambassadors for species that evolved millions of years ago. The detection protocols have already identified dozens of objects that warrant further investigation. Not all of them will prove to be artificial, but the mere fact that we're finding anomalous objects suggests that 3I/Atlas might have been just the first of many such discoveries. Some of these objects show trajectory patterns that suggest non-gravitational propulsion. Others emit radio signals in mathematical sequences that look suspiciously like communication attempts. A few show surface compositions that include isotope ratios impossible for natural formation processes. The investigation teams are being careful not to jump to conclusions, but the pattern suggests that our solar system might be far busier than we ever imagined. If even a small fraction of these anomalous objects prove to be artificial, it would mean that interstellar probes are not rare visitors, but routine traffic in our region of the galaxy. Dr. Amanda Foster, who witnessed the first fragmentation of 3I/Atlas, has been developing rapid response protocols for analyzing new detections. We can't afford to spend months figuring out that something is artificial, she told me. If these objects are conducting time-limited surveys of our solar system, we need to maximize our data collection while they're still accessible for study. The rapid response teams include specialists from every relevant discipline: astronomers, physicists, chemists, biologists, linguists, even anthropologists and philosophers. When a new detection is flagged as potentially artificial, these teams can coordinate global observation efforts within hours rather than weeks. But the most profound preparation might be psychological and spiritual. Humanity is learning to exist in a universe where we are demonstrably not the most intelligent species, where our technological achievements are primitive by cosmic standards, but where our unique perspective on consciousness and meaning might still have value to minds that have forgotten what it means to experience wonder or mortality. The children growing up with knowledge of 3I/Atlas will be the first generation of humans raised with confirmed knowledge that intelligence is common in the universe. Their worldview, their ambitions, their understanding of human potential will be shaped by the reality that we share the cosmos with minds of unimaginable sophistication and age. These young people might be humanity's first ambassadors to galactic intelligence. They're being educated not just in science and mathematics, but in patience, wisdom, and the kind of long-term thinking that could make meaningful communication possible across vast differences in cognitive timescales. Dr. Michael Chen, the theologian who's been exploring spiritual implications of cosmic contact, believes that preparing for next time might be humanity's most important task. 3I/Atlas has shown us that we're not alone, he told me. But more importantly, it's shown us that intelligence in the universe is patient, curious, and apparently benevolent. If we can learn to think and act with similar patience and wisdom, we might be worthy of the conversation that's waiting for us among the stars. The watchers are multiplying, both human and artificial. Our electronic eyes scan the cosmos with unprecedented sophistication, searching for the next visitor that might carry greetings from minds we can barely imagine. But we're also being watched, studied, perhaps evaluated by intelligence so ancient that it remembers the birth of stars. The universe has become a far more interesting place than we ever dared to hope. Whether we're ready or not, the age of cosmic solitude is ending. The conversation is about to begin, and humanity is finally learning how to listen.